All right. So this I wrote on the board the one day that we did the Desmos pet thing. This is the equation, the standard graphing form of a circle. This is the equation that we're going to use. H and K is the center of the circle. The center is not actually part of the circle. It just helps you locate all the points on the circle. And R is the radius. So if we're given this information, center at -3,7 has a radius of 2 radical 7, we can write the equation. X minus -3 squared plus y minus 7 squared equals 2 radical 7 squared. Probably simplifying a little bit of that, yeah. Does it bother you? There's 2 minus signs in a row. It bothers me big time. Does that bother you? No, it bothers me. So x plus 3 squared plus y minus 7 squared equals, how do we do that? We have to square the 2 and the square root of 7. So we're going to square root both of those. We're going to get 2 squared is 4 times what is the square root of 7 squared? 7. So we get 28. Done. That is the equation. So as you're working on your Desmos project that you can't wait to get started on, you will have to have circles in this equation form. The endpoints of the diameter are at 4, 5 and -6, -1. We downloaded our the worksheet. Look right on Monday if you have any questions. And we had that party that he missed. The first 2 minutes of class. That party was so much fun. Now we're all worn out. All right, the endpoints of the diameter are at 4, 5, and -6, -1. What information do we need to write the equation of the circle? What do we need? We need center, and we need the radius. They've given us neither. What can we find if we know the endpoints of the diameter? Okay, hold on. What can we find? You guys are so excited to say this, I know. Kate, we can find the midpoint. What's the midpoint going to give us? The center. So we went over midpoint formula on that worksheet. So the midpoint is just the average of 2 points. We're going to add together the 4 and the 6 for -6. And divide by 2. We're averaging them. And 5 plus -1 divided by 2. I'm sorry, it's messy when I write it here sometimes. We're averaging this to find the midpoint. -1, 2. So that is our center. We did that using the midpoint formula. And we need to know the radius. How can we find the radius? Who's got an idea? Katie? Use the midpoint. Go from one point to the other. What are you trying to find from one point to the other? What's she trying to say here? We need to find the distance, and that was another thing that was in your review. We need to find the distance from the midpoint to one of the endpoints. Does it matter which endpoint? No. So we use our distance formula, which, by the way, is Pythagorean theorem if you haven't been told that before. I'm just going to use the first point and my midpoint because it's first. I'm going to subtract my 2 x's. So I'll go 4 minus -1 and square it. Let's subtract my 2 y's. 5 minus 2 and square it. So that's going to give me 5 squared is 25 plus 3 squared is 9. Then you get square root of 34. And what did I just find? The radius, right? If you can't read my handwriting when I write up here, this thing's like really sensitive, and you can see the numbers stick together sometimes. So just ask. Will not take offense to that. All right, so we're going to write our equation. X minus what number? I got like 3 points up here. X minus -1. So x minus -1 is actually x plus 1 squared plus y minus 2 squared equals, what are you saying? The square root of 34 squared. So 34. When you do the, oops, I wrote 35, I don't know why. When you do the distance formula, when you do the distance formula to find the radius, that's the square root of 34, but if you square it, it's really just the thing underneath it, right? That would be our circle equation. Now you can do all your circles in your Desmos project so far. And lines and absolute values and any trigonometric stuff you need to do. Just don't know how to do those ellipses yet. All right, has a center at 3, 3. And the line 2x minus y equals -8 is tangent to the circle. Do you guys remember in geometry something being tangent to a circle, like what that means? Touches it at one point. How's that going to give me the circle? Do you want to graph the line? Will that help us maybe visualize something? How do we graph it when it's in this form? Intercepts? Okay. My x-intercept is going to be 2x equals, oh my gosh, so messy, -8. So x is -4, -4, 0. My y-intercept would be -y equals -8, so 0, 8. You guys know you have lines on your Chromebook? Do you know your lines? You can make straight lines, do you know that? I mean, if you know and somebody else doesn't know, help a friend. That's okay. I think it's under shapes, maybe? I forget. My students talked about it, but I don't use the Chromebook, so I don't know. All right. How's that going to help me? There's something else that you're forgetting about tangent to circle. Nobody ever remembers the circle rules. That's coming up.
If you use it to find the radius after you put the section.
It's going to have to do with the radius. There's something in geometry that talked about the line tangent to a circle and the radius. Do you remember it?
It's like something like parallel to it, and that gets you like the distance, like the radius of the circle, like
something like that.
the radius of the circle.
You said parallel. You didn't mean parallel.
No, I mean perpendicular. Like it forms a 90, like that, like where that point forms a 90-degree angle with the line. That's
Yeah.
how far like the radius of the circle.
Yes. So there was a I don't know if it's theorem. I don't know. I didn't get that far in geometry yet this year, and last time I taught it was like 5 years ago. But there is a theorem that says when we have the point of tangency in the circle, and you make the radius through that point, it is perpendicular. So if I know that, then I can find the radius that is perpendicular to this line somehow.
Opposite reciprocal of the slope of that.
Slope, yeah. So how do I find the slope of this one?
Negative A over B.
Very good, Neil. So negative A over B is -2 over -1, which is 2. So that's the slope of the purple line. So I need the opposite reciprocal to find my perpendicular slope. Opposite reciprocal of 2, -0.5. Getting there. So I know that there is, and I have a point if I really want to draw there. we have a line, this is part of a line segment, that's going to pass through the center of the circle, that's going to come over and touch this purple line. It's going to be 90 degrees, it's going to make 90 degrees, it's going to be perpendicular there. What do we need to know? We need to find the distance, so what do we need to know? I just use the slope. So the slope's -1/2.
No,
So
the other one, the third one then.
this one?
The next one.
I used the slope again. I went up 2 over 1, up 2 over 1. Do I know for sure that this point that I drew is on the purple line? Right, because I could be a bad grapher. I could make a silly mistake. I don't know, maybe one every hour.
Yeah, actually, you know the slope of both lines.
But did I graph the y-intercepts correctly? I mean, let's not give me any credit here. How do I know this point, which I need to know this point, is actually on that purple line? What point is that? It's hard for me to see up here. -1, 1, 2, 3, 4, 5? Is it -1, 5? What, Amelia?
I have -1/5.
This one right here. Is it
I
on
have
yours?
-1/5.
Is it on the second one on yours? Don't look at mine.
Yeah, mine's on the second.
Mine's on the first one.
Mine's at 4.
Yours is on the second.
Wow.
It's -1/5.
I'm not, I've got it
I just
completed.
use it.
Do you have your point at 3, 3?
Yeah.
Amelia, do you have this point at 3, 3? Did you go up 1, left 2?
Yeah.
Did you go up 1, left 2? So maybe it doesn't cross there.
I didn't cross anything.
Okay. Regardless of what you have or what I have, because it might not cross there. I'm just going to plug this point into this equation to see if the purple equation actually passes through that point. You see what I'm saying? I'm just going to plug it in. So let me check that. 2 times -1 minus 5 has to equal -8. So I plug that in and I get -7 equals -8. So does it cross there? No. Okay. The problem is my purple line doesn't cross there. So now I'm going to go back to what Neil said. Do you think maybe we need to find the y-intercept and find the equation of this blue line? Okay. Ultimately, I'm trying to find the distance of that. That's what I'm trying to do. I'm trying to find the distance. So once I know where the 2 lines cross, that's going to be my other point. So I'm trying to find the distance. Oh, you mean where it crosses? How do you know?
That's where it crosses on mine.
But you have to plug in an X and a Y.
I did.
Oh.
And 5 and E5.
It can't be. Not on the blue line.
The purple one.
But it can't be on the blue line. So what I'm going to do is I'm going to find the equation of the blue line, which we learned how to do. You are struggling, man. We're going to find the equation of the blue line, which we did in chapter 1. And we're going to use systems to actually find where they cross, and we will have the point at which they cross. Remember how to find the equation of a line. Yep, y minus y1 equals m times x minus x1. This is a good reminder because we are going to have lines in this chapter too. So good to go over this. So if I do y minus y1, I know that it passes through 30, and we know that our slope is negative 1/2 x minus 3. So y minus 3 equals negative 1/2 x plus 3/2. Add 6/2. Okay, so we got the equation of the blue line. You guys help me out because I don't want to have to scroll up and down. What's the equation of the purple line? 2x minus y, is it? Is it negative 8 or just 8? Negative 8? Okay. So how do we solve that system? Yeah. Substitution? Sure. Go ahead and do substitution. She wanted me to scroll up so I can't write yet. Go ahead and do substitution. Did you already do substitution? Did it already? Amelia? Go ahead and do substitution. Solve that system. You mean we're still doing that? Yeah. Okay, you're good. I just, okay. All right, so that's going to be 2x equals. Okay, check my math. I got negative 7/5. Did you get negative 7/5? Did you get negative 7/5? How? It's not even on. Oh, you weren't. You were writing your signature 100 times. Like you're going to be famous someday. You got to practice.
You can have an ask if you wish.
What did you say?
I said you can have an ask if you wish.
Oh, yeah. What are you going to be famous for? Sorry. Not yet. Okay. Me too someday. Yeah. All those passes that I signed for you guys to go to the bathroom, you can hold on to those.
I still lose.
You do. You know ahead of time. You know, side business. Okay. All right. Does anybody want to like say, "Yep, that's what I got," or "Nope, that's not what I got"?
Yep, that's what
Okay, that's okay. Okay. All right, so plug it back in. Let's see what we get when we plug it back in. Oh, it's such a lovely answer. 2 times negative 7/5 minus y equals negative 8. Oh my gosh, this does not write well. It's impossible to read. I'll redo it. Does that help? I changed that into negative 45th so I could add 14 fifths. Okay. And then I got 26, well, I got negative 26 fifths, but made it positive, so y was positive 26 fifths. Okay, so we have an intersection point. We're done, right? Oh, no. No? Not yet. Almost though. We're so close. What do we need to do now? We're going to do our distance formula to find our radius. The radius and the distance formula are the same formula. Just Pythagorean theorem. So we need to subtract our x's and subtract our y's. I'm going to rewrite the ordered pairs we're using right here. We're using 3, 3. And we're using, oh, I already forgot what it was. What's the x? Well, this is 26, not 25. I'm sorry. I don't know why I wrote that. I'm going to have to ask you that same question again because I didn't listen when I noticed I wrote something wrong. What was the x? Negative 7 fifths.
Is it the same as the Pythagorean theorem because it like makes a triangle?
Mm-hmm. That's exactly right. We're finding the difference in the x's, the difference in the y's, and then we're doing a squared plus b squared equals z squared. Yeah, so sometimes I'll do it on the graph because it's faster. I'm trying to spell cheat a little bit. 8x squared plus. Oh shoot, that's wrong. Don't pay attention to me. Do it yourself because I make mistakes. Don't worry, this is like the hardest problem we'll do, and it's probably harder than any of them on the homework, just so you know right now. Just so you know. Way harder than any of them on the homework. I feel like I changed the question in the past, but I didn't. So we're just going with it. Oh, I see the other one. Okay, I just used my calculator a little bit. Hopefully I did it right. We have to do all that work to find the distance. But good thing it was all like Algebra 1 stuff. What was our goal for this whole question anyway? I didn't understand you. Write the equation of the circle. That's what it was. So x minus 3 squared plus y minus 3 squared equals what? (121/5). It's just that easy. None of them on your homework are that hard. Trust me. But it's still like the same steps. It's not gonna be horrible answers, okay? It was fun though, right? Yeah. Okay. State the center and radius of the circle and graph it. What's the center of the circle? -1, +3. Radius is 2. So we go to -1, +3. And then for a radius of 2, you go out 2 in every direction and you draw a circle and we're done. How about that one? Center. 4, -3, And we go out how far? How far do we go for radius? Square root of 5. Okay. If you don't know what square root of 5 is, it's over 4. No, it's not over 4. Over square root of 4, sorry. It's greater than 2, less than 3, or you could just be like, what's the square root of 5? You'll have calculators for this section. 2.2-ish. So from here, I'm going out 2.2-ish. Did you hear that? You'll have calculators for this chapter. Can you believe it? It's a miracle.
I thought we didn't have a test yet.
Oh, you'll have a test.
I thought the Desmos was.
No, Desmos will count as a test. What? Will be in the next quarter. The test will be over, like, being able to tell me that you know the radius of this circle. Like, the bits and pieces, the Desmos project is a project I'm going to count as a test grade, so you can, like, get points a different way. Rather than just a pen and paper, you have to recall information. It's just a different kind of assessment. What'd you say?
Takes the place.
Takes the place of, huh?
Of homework.
You could not do your homework. All right, so I think this is the last section. You need to write the equation of the circle to be able to state the center and radius of the circle. So this circle is not given in the form of that standard graphing form. So we have to put it into that form. What you notice about the standard graphing form is that we have perfect squares in the standard graphing form. Bless you. We have perfect squares in the standard graphing form. And what was on that assignment that I asked you to do? There was distance formula. There was midpoint. There was what? To make a perfect square trinomial, and then after that it was complete the square. In order to do this, you have to understand complete the square. So, tiny crash course on part of complete the square. This is not solving by complete the square. This is just reordering and writing an equation by complete the square. So in order to do this, you have to have all your x's and all your y's kind of collected together. So right now I've got it all mixed. I'm going to reorder this so that I have x squared minus 14x. I'll leave a space. Reorder this so that I have plus y squared plus 4y. I'm going to leave a space. I'm going to keep reordering so that I have equals 0, and then I'm going to put my plus 11 over there. Okay? That is what I choose to do to make it easy and organized so I can do my next steps without making silly mistakes. When you complete the square, you figure out what you put in to make a perfect square trinomial with the information that's already given. So those of you that didn't do your assignment, I'm still like going over stuff that's on that assignment, so maybe hopefully by Monday it's done. Negative 14x is what you look at to complete this square. We divide that number by 2, and then after we divide that number by 2, we square it. So what's negative 7 squared? 49. But if I add 49 to one side of the equation, if I add 49 to one side of the equation, what do I also have to do? No, I need to add it to the other side. If you looked at something else online that said add it and subtract it, that's fine, but they're doing it on the same side. That would be when I didn't move the 11 over. So there's different ways of doing complete the square, and your choice is fine as long as you follow correct math rules. All right, so same thing with the purple one here. If I take this middle term 4 and I divide by 2 and then I square it, that's going to be 2 squared, which is 4. And if I add 4 to one side, I've got to add 4 to the other side as well. So on my right side, that one's easy. Tell me what do I get? Now on the left side, we are going to continue and factor the left side. So we purposely chose these numbers to go in here so that these are perfect square trinomials. So they will always factor to be perfect squares. That's why we chose that number. So right here, I will have something squared. And in in the purple, I will have something squared. That something, if you want a shortcut, is, well, x. And then what goes here is whatever you had before you squared it. So -7 or -7. If you want a shortcut. Or you can actually just take your time and factor it. It's going to be the same answer. What goes in the purple one is going to be y. And then what goes in the second part is whatever you had before you squared to get the 4, whatever you had here, which is a +2. So now it's in that form. My center is where? +7, -2. And my radius is 8. That's fine. I just want to turn that. So the very next one is one that's exactly like this one. Can I give you a moment to try it on your own? The very next one, see if you can do it. I haven't switched my screen over because some people might be still popping down my work. I'm about to change the screen if you don't have it in front of you. Why do I have headphones in? No, I'm trying to take them off. I don't have them in during this. What is it? 79? 79. 79?
Oh, it's -27.
You guys got 25? What would happen if it was a -79? Just you said 79, but what would happen if it was a -79? So what would happen? Would we have a circle? No. What would happen if it was a 79? We would. It just wouldn't have a nice, easy radius to graph. Center is 6'4", and radius is 5. Any questions on this one? Circles are easy. Find the equation with the center 3, -2 contains the point 8, 2. This is the last question. 3, -2 contains the point 8, 2. I know this. I know that part. I just think it's easier to get rid of it so I can just see those perfect squares. So how do we find the radius? We need the radius. We know the center. What's that other point telling me? This other point is on the circle somewhere. That was a good circle. So that's telling me if I find the distance, we will have the radius. Because the radius can be anywhere in that circle. So distance formula. Pythagorean theorem, if you want to do it this way. Did I do my math right? I get nervous. I make silly mistakes. Alright, so that's it. It's a worksheet. It's on that stuff. Nothing will be as hard as that one question I gave you, I promise. We will not have a test before the end of the quarter. It's next week. So any assessments from now on are going to be on fourth quarter. I'll get your